load of that certain object, atong applied load. Okay, so stress is always force over area or P over area. Okay, so for the area, kung unsay shape sa ato ang object, mo ato ang area or kung asa na-apply ang ato ang loading. Okay? So, this is also very important class, the units. I hope you are familiar with conversion, especially for metric system, because I am mostly gonna use metric system. I'm not gonna use English. So, commonly used mo ang metric. So that is the meters, kilonewtons, diba? So, during my time when I was taking up this subject, I don't know how to even convert centimeters to millimeters. Kailangan mo ni Sir Malongo. Class?
Wala, ma'am.
Wala, ma'am. Ay, wala magudin. May face-to-face na meet magudin niya siya.
CE, di ba naman?
CE. Kuha na siya ME. Pero matulog na siya mga EE. Wala na siguro siya kakuan. I don't know, Bea. Okay. Wala naman po tayo atong school. But Sir Malongo is terror po na siya first time. He was my strength of material instructor. Dayon, during the exam sa una, he gave us kanang sa isa ka problem different units. So na ay cm, na ay mm, na ay meter, na ay newton, kilonewton. So naglibog ko, oh my god. Naglibog ko pila value sa meter, millimeter o cm. So I was very honest but nga I don't know jud kay nag-study ko, grabe akong study, pero ang kanang units kay akong i-disregard, so nalibog na hinuon ko. Nga, wala na ko siya sa tawag na, gitagag attention nga makalibog man di ay. So, I came up to him, sir. Saan pag-convert sa... Tinood dyan siya kasi nga, saan pag-convert sa mm to cm? Iyaman ko anang giingnan. My God, pakaulaw ka. Third year na nag-engineering. Hindi kaya pong kakabarong yung daghan kay ko classmate niya. Naghinay ron to ko. Sir, saan pag-convert? Because dako bang ko kayo siya og points class ba if di na ko ma-answer niya. Naulaman ako. Pag ko ka-answer. So, mara to siya. Lesson learned. So, kada ato, ako nang pisag binagagmay nga mga details. Dapat inyo dyan silang i-study gihapon. Do not take it for granted. So, pero after ato na motivate ramon po ko, so nakapasa ramon po ko ang pero wala dito siya. Kaya ako siya tingog man siya nga, my God. Anyway, so I want you to study jud conversion class kay bisag mo graduate na mo and bisag na engineers na mo, pinaka commonly used gid na siya. So niya mo yung mga trabaho, so you have to be aware or familiar with the units and conversions. Okay, so our mostly used here unit is the Pascal or the Newton per m squared. So they have certain equivalents. So for MPa, that is 10 to the power of 6 Pascal, and GPa or gigapascal, MPa is megapascal class. Gigapascal is 10 to the power of 9 MPa, and we have kilopascal or kPa, 10 to the power of 3 Pascal. So that na siya So sometimes MPa is also in Newton per mm squared. So convert lang ni siya class. Okay? So, let's move on now to the next part. So, the next part is the types of stresses. So, there are two types of stresses, the normal and the shear stress. So, when you say normal stress, so this is normal stress. It is when a perpendicular area, the resisting area, like this, is perpendicular to the applied force. So what do you mean by perpendicular? Kani, di ba natin stress 1. So perpendicular siya sa kaninga area. That is what you call a normal stress. So this normal stress is then divided into two kuan. So we call biaxial state of stress duwa yung kuan, then kani triaxial tulo. Okay. It is then divided into two types of normal stresses. We have the tensile, or some say tensile, and compressive stresses. So tensile stresses are applied tends to elongate, while compressive tend to shorten the bar. So when you say tend to shorten, ga-push, while the tensile is ga-pull. So makita naman po ninyo class, di ba? So that is the difference between the two. But they are
Same na
both.
sa ma'am.
Yes.
Same na sa tension o compression, ma'am, no? Di po.
Mauna na siya. So
Okay.
that is compression and the tension. So when you say tension, it is a pulling force. And compression, ga-compress, it is ga-push. So when you say push, it tends to shorten the bar. So ato siyang ipislat. While for the tensile, it will elongate, or it tends to make the bar elongate. Okay, so kuan lang, remember lang that. But they're both normal stresses. Okay, so our stress here is still equal to force over area, or P over A. So what is the A here? The A is the area where the force is applied, perpendicular. Okay, basta compressive, ang atong gamiton ni area is perpendicular area. Okay, kanang mara siya giti. Okay, yun na siya. So there is also another type of kuan, of normal stress, which is the bearing stress. So it is a compressive stress in a sense that it is still causing stress to the applied area is still perpendicular. But the difference is it's not the difference. The main the definition of bearing stress is the area of the stress is the contact pressure between the separate bodies. So as you can see here sa atong figure, we have two objects, the object and the soil. So we have a force. The force applied here is the force of the object. It is carried by the soil. So when you see contact force or the contact pressure between the two, the area you are going to use for the force over area here is the contact pressure ani nila. So kung asa siya nagtapot, maura po to ang area nga na ay stress. Okay? So that is bearing stress. It is still it is still a normal stress. Okay, perpendicular man gihapon siya class. Diba? So this is what you call bearing stress. So let's have more of that later on. So let's move on to the other type of stress, the shear stress. So this is actually different from normal in a sense that the forces or forces parallel to the area resisting the force cause this. So, di ba ganiha kay normal or perpendicular? Karon, nanatay force nga ga parallel. So, sometimes makuan ni siya class ma-confuse. Sometimes you become confused with shear stress and bearing stress kay usahay they are both like in ani mura pa siya ang bearing manggod di ba contact force na igapatong, but for shear the force is parallel siya class. So can you see di ba ganiha ato ang kung bearing kay gapatong so natay gapanaog nga force or ga-push, it is normal. For shear natay gapa murag ang iyang direction sa iyang force is parallel sa area like that. Okay, so when you say parallel, that is shear stress. Shear stress is denoted as kaning nga symbol sa gani siya tau. Okay, so where P is still the total force and the A is the area over which it acts. So asa nag-act ang atong shear stress? Parallel muna siya. Parallel ang area class ha. You have to remember the difference between normal and shear. But they're both the same in unit class. MPA, PA, siya pressure ba? Okay, so I'm going to give you an illustrative problem for our topic. Sige, understand sa ito ninyo. Na ba may questions? Wala na. So, buhatag ko ninyong illustrative problem. So, a hollow steel tube with an inside diameter of 100 mm must carry a tensile load of 400 kilonewtons. So, determine the outside diameter of the tube if the stress is limited to 120 meganewtons m squared. So, how do you think you're going to solve this problem? Sa inyong pinakaunang buhaton. Okay, if I were you, if I were to solve the problem, I would first list down what is given or what are given. So we are given here an inside diameter. So it's up to you what you're going to designate for the inside diameter. So D, nga dako na lang. Okay, ay gagamay since inside man siya. So smaller diameter siya. So tanga to 100. Ay, pwede mo siya solution. So, gani 100 mm. So, this is how I solve the problem class, or this is my way of solving almost all of the problems sa college pa ko class. I write down what is given to lessen the hassle para di na maglibog. The next given is the tensile load. So we are given here a tensile load. So pag ingon pa lang ng tensile load, normal stress na ni siya, automatic. So when you say tensile load, the normal stress perpendicular. So ang area is perpendicular. Ano na siya? So butang na to 400 kilonewton. Then we are also given the stress. So since tensile man ang atong load, meaning atong stress is normal, so ano siya, sigma. So we have a sigma of 120 meganewtons m squared. So kira or kinahanglan tang mag-convert. So next, what I am going to do is I'm going to determine what is required. So we are asked here to get the outside diameter of the tube. So if the stress is like that, so write down ninyo D nga dako, designate D nga dako for the bigger diameter. So question mark siya or siya gipanghita. So analyzing, so muna ni siya mohimo na tag free body diagram sa atong given. Okay, asa man to tong free body diagram? Muna ni siya. So we have here a D nga dako, kay hollow man daw. So when you say hollow steel tube, inani yang itsura, bangag ning sa sulod. Dayon nado siya tensile, so we have a force going down kay ga pull, dili compress, ga pull siya, so going down ang atong force which is 400 kilonewton, and we have a hollow steel tube with an inside diameter of 100 and an outside diameter of 100. So, saan man ni? What is missing here is the area. Since sa atong stress nga formula, diba natay stress nga formula as equation 1, force over area or P over area. Then we have already So we have first equation, force over area. So wala man tay area, naman tay P, naman tay stress, we are going to get the area. So what is the area of a hollow circle? So for the area, we are going to subtract the smaller circle from the big circle to get the hollow lang. Ato lang hollow circle. Okay, so what is the area of a circle? That is 1/4 pi d squared. So for 1/4 pi d squared minus 1/4 pi d smaller squared. Okay, so wala man tayo value sa atong koan, di nga dako, meaning mo na siya ato ang panghitaon. So substituting, we have 1/4 pi d squared, the same lang yapon, and 1/4 pi 100 squared. So since na naman tayo value sa itong gamay nga t, we are going to simplify that, making area as 1/4 pi atong i-factor out na to make it like this, d squared minus 10,000. So ang value sa itong area is now like this in terms of d. Since we are looking for d, automatic na to siya i-substitute diri sa pikas. Uy, nawala. Substitute na to siya sa pikas. So we have 120 sa atong stress P. Atong P here is, sa ganito, 400. Muna siya ang pag-convert class. First, convert the koan. Convert na to ang atong 400 kilonewton into newtons. Since meganewton is also 120 newtons per mm squared is still equal to 120 meganewtons per m squared. Equal na sila class ha. So you convert the newton na lang para ma-kuan siya, the same siya og unit. So substituting, we get d as our koan, missing. Saan man ni? Simplify, transposing, like that. We get d is equal to 119.35. Okay? Do you have any question?
None, ma'am.
None? So do you
None, ma'am.
understand lang? Yes.
Yes, ma'am.
Okay,
Yes,
very
ma'am.
good. Kana, that's the spirit. Charot. Ano man eh? Yan na yung tinuwag pressure vessels. Okay, class. I am going to give you an exam with this topic. Lang, shear and normal stress. Exam ta ha, Friday. Problem solving lang tanan. I want you to study more. Ang akong source is Andrew Paitel lang libro class. Strength of Materials. You can study that book if you have. Then we will have our exam.
Yes, ma'am.
Ay,
mga email.
Paitel Ha? Oh, I will upload this
Di ka matag sa imong
classroom.
TPT, ma'am.
Matag ko ako ni-upload sa classroom class later on.
Sige, ma'am. Thank you.
Okay, doon mo ha, Friday. So, katong mga nisulot na karon from section B, it is okay na to come on Wednesday na. So, for those who have not, please join kay kuan. I hope would also katong uban kasi pwede mo maka-record and you can share it with your other classmates. Okay. Ay, wait. Isa muglaka. Okay, mag-screenshot pa di ko. My God, may online. Apoy ba?